Hello, my name's John Capobianco, and recently I've been exploring the world of agentic AI, artificial intelligence agents in the form of reasoning and acting, REACT agents. Now, so far I've had very good success with things like PyETS and network CLI commands, but I wanted to see if my theory and my ideas of using agents with REST APIs, representational state transfer APIs, which are similar to a web UI, but instead of giving us a graphical user interface with images and text, it gives us back structured JavaScript object notation, which artificial intelligence, given it's a machine language, is very good at using. So many systems, the backbone of many enterprises and many solutions revolve around the REST API, including more advanced forms of network automation and running things like software-defined networks, SDNs, that have a central controller, and the controller controls the fabric or the infrastructure. And what we can interface with is the controller, not the underlying infrastructure, often in the form of REST APIs. Now there's tools like Postman or ThunderClient, different graphical user interfaces. Pythonically, we can use the requests library to do API calls and get JSON back. But can we just be done with all of that? Be done with the friction and just talk to our API endpoints or our systems and invoke the correct API automatically through agents. So with a natural language interface, can I ask questions and have the AI use the reasoning to, one, determine that it needs to use a tool to answer the question, two, pick the correct URL for the API in question, three, take the action of invoking the function with the correct URL, and then analyzing the JSON payload to help answer the original question. If this sounds like a lot, we're going to start really small here today with some Pokemon. So Pokemon has an API on the internet, PokeAPI, that we can use to explore traditional ways of using REST APIs and now agentic AI ways of using REST APIs. Now I'm not gonna stop there. That's gonna be to help conceptualize this for you with an arbitrary API, the Pokemon API. The next thing we're gonna do is move into the world of data center management with Cisco APIC, the Application Policy Infrastructure Controller, for the ACI network, the application-centric network. This is a software-defined network that has a controller that is made up of purely REST APIs that we can make agents for to interact with. Thank you for joining. I do recommend you watch some of the previous videos, but this will bring you up to speed very quickly on agentic AIs for REST APIs. Stay tuned. So first, let's start with what is a REST API. Now, I found an arbitrary image that I thought was pretty simple and easy to understand from manhowie.com here. We're going to have a client, our PC, which is going to have software or code that can make an HTTP request that performs a CRUD activity: create, read, update, or delete, in the form of these verbs like get, post, delete, or put. It's going to need a URL, a path, where the payload can be found, the REST API's endpoint. This is going to be pointing to a server, and that server is going to respond with a response code, hopefully in the 200 series, meaning success, and JavaScript object notation as a payload. So if we take a look at Pokemon's API, the PokeAPI, we can just try it out and go to HTTPS PokeV2, and if I put this in a browser tab, and let's put the full Pokemon Charmander here, it's going to be the JavaScript object notation of this Pokemon. Now it's quite verbose, and that's a lot of data for a single context window in terms of artificial intelligence. So we're going to trim that down a little bit. But you see the idea here is that instead of a graphical user interface with a GUI and buttons and text, we get structured data back in the form of JavaScript object notation. Okay? Now I can use a tool like Postman to get all of the Pokemon here, and it has the name and the URL. Now this is important. We're going to be using this data here to help our artificial intelligence know the API path to find the Blastoise in case in the natural language the human asks for information about Blastoise. Okay? So let's take a look at how we're going to do this. We're going to do this through a system known as React. This is the agent type we're going to use. So the agent's going to start and have some thoughts. The LLM thinks based on given prompts and observations. It's then going to take action and provide action input, make observations, and do this in a loop iteratively until we come to a final answer and the agent finishes. Now this is from this Medium article, Implementing React and Function Calling Agent Types for Efficient Natural Language Reporting. And this is from December of 2023. So it's not cutting edge, but I am finding some real great power with these agents. So let's start our Pokemon code here, and then we'll look at the code. So what we have here is the JSON, which is the list of the Pokemon's name and the URL as to where to find the JavaScript object notation, the REST API for this Pokemon. Now our code, I've swapped out LangChain Ollama for LangChain ChatGPT, and I'm using my ChatGPT key here for optimal results. It will work with Ollama, but it works much, much better with a paid service like ChatGPT 4.0. All right, I'm using Streamlit to present it, and I'm simply using JSON and requests, as well as some LangChain tools. So the requirements file, I'm going to add OpenAI here, has just a few pip installations that are required. So we're going to have some functions here, one to load the JSON Pokemon file, one to find the URL in the file, one to get the name from the URL. So then we have decorator tools that the AI is going to have access to in a list of tools. Fetch the Pokemon info, and I think that's the only tool I actually have for this agent. So we're going to find our LLM as ChatGPT here, GPT 4.0. Our tools is the Fetch Pokemon Info tool. We're going to render the text descriptions for the tool. And then we have this fairly complex template that explains to the tool, to the AI as instructions to do the reasoning and actions. Okay, so it has some examples, it has some thoughts, and it provides the input from the user and a scratch pad at the end for it to do its work, for it to figure out its reasoning on a scratch pad. We just need to pass a couple input variables in the scratch pad, which is empty, to the template. We're going to generate a prompt template. We're going to create a React agent. We're going to execute the agent with an agent executor down here in the Streamlit code, where we do agent executor.invoke, the user's input, and an empty scratch pad. Okay, so how does this work? This one's for Pokemon. So what we can do is we can ask it something like, let's say, what can you tell me about Bulbasaur? Send. Now it's pretty neat here. I got to get here fast. I need to fetch information about Bulbasaur to provide a detailed response. It runs the Fetch Pokemon Info tool, which gets this JSON payload back, which results in this nice answer from the AI, and we present that here in our Streamlit. It even has the sprite. It even has the little Bulbasaur image. Isn't that cool? So, we could even do Pokemon battles, I believe. So we can say, who would win between, let's say, a Pikachu and a Jigglypuff? And we're going to send that. So now what's going to happen is, it's actually going to get, you can see it here. It needs to get two Pokemon's information. I need to fetch information about Pikachu, fetch the Pokemon info. Here's the Pikachu JSON. I need to fetch information about Jigglypuff to compare them, and it gets the Jigglypuff information. And then it actually simulates a battle based on their statistics. So what does it come to? A conclusion. Speed. Pikachu is significantly faster, which means it will usually attack first. Defense and special defense. Jigglypuff has low defenses, making it vulnerable to Pikachu's attacks. HP. Jigglypuff has much higher HP, allowing it to withstand more hits. Attack and special attacks. Pikachu has higher attack stats, giving it stronger offensive capabilities. The conclusion is, while the Jigglypuff has higher HP, Pikachu's superior speed and attack stats give it an edge in battle. Therefore, it's more likely to win in a direct confrontation if it can exploit Jigglypuff's low defenses. So, an artificial intelligence Pokemon battle using the real statistics from the Pokemon API. Pretty cool. Stay with me. We're going to now look at the world of how this can be implemented for, let's say, network automation. So, what we have is an APIC. This is the central controller that controls the network fabric in a Cisco data center. You can see that I have a spine and two leaf switches in this topology. Now, you can see that it's quite extensive. All of these menu systems, and they all have sub-menu systems and side menu systems. Wouldn't it be great if we could just talk to this thing? So, using the API system, the management information tree, everything you see here has an underlying API call. And there actually is a tool here, the API inspector, that will show you, if I click on an API, let's say tenants, and I go back to that API inspector, you can see the API call here went to an API called tenant, fvtenant.json, right, to get the tenant information. And it displays the tenants. So using and exploiting these APIs, by the way, here's the getting started guide. We need to first authenticate against the APIC with our username and password, which will give us a token or a cookie, and then we use that cookie for subsequent API calls. That in itself is maybe a challenging feat for most people. So instead, in our code, with this React approach, can we then instead, and let me kill the Pokemon code for a second here. I have to stop this. And let's go back over here and Streamlit run ACI agent. Now I have a similar thing to the Pokemon. I have a list of URLs, tenants is the name, fvtenant is the URL. And I have about 250 different APIC APIs, some of the more popular ones and more commonly used ones and important ones mapped in this file. Okay, so I have a class here that will take the username and password in the APIC URL to get a token. So there's my token code, and get an API. We're going to load the URLs from that file, and we're going to check the URL that the AI wants to use versus our supported APIs, just to check that this is a supported command. If not, use the closest supported command, meaning path. So we have a tool here to get ACI data, and that's it. And a tool here to check the supported URL. So we're going to process this agent response. right? Pass it a list of tools, pass it the description. Here is our template for this agent system. Our input variables, our prompt template creation. We're using ChatGPT here. Set up an agent, set up an executor, execute it when we click send. Executor.invoke. More or less the same as the Pokemon, except we're using an APIC in the data center. So let's check this out. And let's ask it if we can get a list of tenants. Can I please, how about a table? Get a table of my tenants. Send. So we should get heroes, management, SNV, maybe infra. So there's a few tenants there. So do I need to use a tool? Yes. Check the supported URL tools. We're going to use tenants. And it has a closest match of FV tenants. Here's the tenant JSON, and we have 5 tenants. And I should have 1, 2, 3, 4, 5 in my table. And here is my table just by asking it, can I get a table of my tenants? Now, I don't know how well configured this fabric is. We might be able to ask for something like the fabric membership. It does have leaves and spines. And again, I'm kind of flying blind here. Let's just try a command here. How about what can you tell me about my fabric? Send. And now this is going to pick the fabric pod. And it came back with some information about our topology, that we have a single pod, which is a physical pod, and here is the policy DN. It even responded in a table, even though I didn't ask, given the history of the commands, right? So do I have any L3 outs? How about something like that? Now, I don't know if I have any L3 outs. And it did come back with some L3 out information. So truly a conversational interface into the APIC by providing it a valid list of URLs and their names, their natural language names, and this React agent approach with LangChain, and I'm actually using ChatGPT here. So how about something like bridge domains? What can you tell me about my bridge domains? And it will likely come back with a table. And it's checking the right URL here, bridge domains. And this might have quite a bit of data. And there's all of our bridge domain data. Quite interesting, right? Now, I don't know that I can put or post right now, like create a new bridge domain or create, and it has all of the information here, right? Unicast action, multicast action, broadcast IP, MAC, all this great stuff just through a conversational interface. And I guess the next natural step would be able to add an agent, add a tenant or something just through the natural language. But again, I would need to modify my tools to give it a tool to do a post. I have not yet tried that, but that would be an interesting exercise. So again, this is the world of AI agents, which might do away with things like Python requests or postman or the manual process of interacting with AI APIs using AI agents. Now, so many of our systems have REST APIs, and so many of us have existing working Python functions that are easily decorated as a tool and passed along to a template that provides the reasoning and actions instructions to an LLM so that it can run that code and analyze the payload. Now, I've done this with Ollama and Llama 3.1. Maybe a larger version of Llama 3.1 might perform better, but currently I'm having the best results paying about 3 cents per agent call with ChatGPT 4o. So your mileage may vary, but you can do hello world and getting started and small chunks of data set, small JSON, no problem with Llama 3. Some of my API calls are resulting in larger chunks of JSON, which means I need larger context windows and a more capable LLM. So I would get started with agents right away. I would start with REST APIs with something like Pokemon, like I showed you. Just get it going. Just get something working. Find a fun REST API. We've explored Marvel Comics and Star Wars and all kinds of video games, and there's Minecraft APIs, all kinds of great stuff that you might be able to start writing AI agents to interact with these REST APIs. My next steps are going to be to see if I can do more than just read in the CRUD activities, create, read, update, delete. Can I create, can I delete by expanding on my library of functions and let the LLM take something like, could you please create tenant John's tenant and transform that into a post or a put. I don't think that's going to be very challenging, but that will be my next step. So stay tuned and thank you for joining me on this journey. As always, the code is available in the description, and I'm here to collaborate if you have any questions or feedback. All the best.